School Counseling Week continues. Check out the TV in the Commons once I get it turned on. Check out the TV for giveaways. Celebrate our counseling week. Keep up still telling candy grams. We'll be selling in today during Spartan time. ACT, big test this Saturday. Math reviews and practice sessions be tonight in Mr. Sullivan's room. Thursday in Mr. Jameson's room, both after school, and Friday during Spartan time in Mr. Spears' room. You can attend all three, but one will be better than none. One will give you the information that you need. Seniors, again, check your email and you can receive various items on approaching yearbook, slideshow photo deadlines. Those of you who might be interested in the graduation speech, that deadline's coming up. Different items, you need to check your email. Advisory day next Tuesday. Make sure you plan accordingly. You all need to attend Spartan time next Tuesday. Also next week, Thursday, third quarter midterm ends. Should you plan for that? See your teachers during the Spartan time coming up. Remember, we'll have a band performance today. All the band members will be attending during Spartan time. That begins at 2 o'clock. Anybody else who wants to take their Spartan time there, you're more than welcome to do so. So please stand for the pledge. Please do the pledge. All.
Okay, they last like at least a week after that, but I'll plug them in this weekend. So we're now like, what, 3, closing 4 weeks in. You're going to start seeing those calculators start to say low battery. They last at least another week after that, okay? Chill. If you're using the calculators in class, I'll try to remember to plug them in over the weekend. I never plug them in the room because the capacitors on the charger scream at me and give me a headache. If you're one of the kids who can actually hear like CRT monitors, tube TVs, outlets, things like that, when you hear that high-pitched squeal, A, one of us, B, you know what I'm talking about. If that sounds completely alien to you, be grateful.
I can tell if that's like eat my lunch. Girl. At 9 in the morning. 8 in the morning.
Type of food for particular meals is an artificial construct. You eat what you want. Breakfast for dinner is one of the best choices you could ever make. Okay, since you're over there making lunch, are you done with this?
Yeah.
You might want to do that.
I don't understand it.
Careful about B. There is a particular type of notation that we're looking for. We did talk about it. It's a tiny, tiny little detail in how you write your limit. It's not what your neighbors know, it's what you know. Who needs more? Thank you. 5, 3, negative 84, 5, 16, 4. If you remember, we talked kind of reviewing about rational functions. Again, we're going to do it. What's rational functions? 2.5, I think. We're going to review through rational functions and put a little more spice on it. But the idea is if I've got degree is the same, numerator and denominator, whether or not things cancel out, if there is any rational function remaining, that means I'll have a horizontal asymptote at y equals a over b, where a and b are the leading coefficients of your numerator and denominator. So this is going to have a asymptote at y equals 4. And since it has an asymptote at y equals 4, that means the limit of f of x as x approaches both positive and negative infinity is 4. Okay? Or you dump that in your calculator, go to table ask, spam 9s, or in your case 7s, and it'll say really, really close to 4. Okay? In fact, if you put enough of that number in there, if you make the number large enough, your calculator actually just kind of gives up and says 4. Okay? That one, if you remember transformations, this will go right 3, up 1, and have vertical stretch of 2. So it's going to look like this, with, it's not really a vertex, more like an origination point at 3, 1. So we're probably good with the limit of, did I say g? Yeah, g of x, as x goes all the way to infinity, is infinity. And then we see who remembered, paid attention, wrote that special note when I said, hey, you should write this. What is end behavior? Like, what is it? The tendency of y's as what? As what happens? As x goes where? Not necessarily to plus or minus infinity. End behavior is what are the y's doing as you approach the ends of the domain. What's the end of the domain on the left of this function? 3. So I say, as x approaches 3, not negative infinity, and because I can only approach it from the right, this was our very first example, put a tiny little plus on there to say that I'm only approaching it from the positive side. And as my y's, or as my x's come at 3, my y's are getting real close to 1. Okay, this was our very, very first example. If you look at the beginning of section 1.3, that little graph down at the bottom, remember the graph started down, it was like at -8, -10 or something, closed circle. And we had said, as I approach -8 or whatever it was from the right, my limit is -10. Same deal. Okay. Is there anyone who wrote the end behavior for A separately? Because that's cool too. If you said as it goes to positive infinity, it's 4. As you go to negative infinity, it's 4. That's cool. It's just when they're the same, you can shorthand it like that. So, did you have correct limit notation with both positive and negative infinity together or separate? Correct limit. I'm betting everyone had, you know what, actually I'm just going to say this is for limit notation correctly. There we go. For having it correct. For having it correct. For having it correct. For getting the correct end of the domain. Now, if on part B you had said, as x approaches negative infinity, does not exist. We missed 2 important relevant parts of limits. Okay, Normally, if it's a single thing, I would say 4 out of 5, but that's why I got 2 points down there, is that's kind of a big deal. That we do approach the ends of the domain, not always positive, negative, infinity, ends of the domain. That is a big, big concept, okay? Now, to be fair, if you had said as x approaches negative infinity and then doesn't exist, yeah, I would say that's 4 out of 5 because at negative infinity, it doesn't exist. So you just didn't understand the definition of limit or definition of end behavior. You understood the definition of limit, not the definition of end behavior. Yeah, I'd still call that 4 out of 5 because that's a domino. I can walk that back. So, the assignment. Holly had a really good question, and this is what happens when you change the directions on the fly, is sometimes you get a weird case that wasn't really supposed to happen. What number was it? Remember?
26.
26. Come on, you. There we go. Okay. So the question was, if it's an open circle, is it actually an extrema? Right? Like, it's not the point where it's switching. And I got to be honest with you, I don't know if that's ever actually come up in PreCalc because we've never done extrema with a hole in the middle of our graph. Normally, we do it with just polynomials. So I just kind of winged it and said, hey, I want to do some extrema stuff with these. And I would say that's 4-2 itself is not an extrema, but how could we, like, as a group, just think about this. Combine what we said with approximate coordinates, with limits approaching things, all of that notation. How could I still say, look, I know it went down and then it went back up. So there's something there, but I can't say it's at 4-2. How would we say this? How would we try to wiggle out a definition of extrema there, knowing that 4-2 is off limits? It's kind of like playing the game Taboo. You ever done that where you have to get them to guess this word without saying any of these words associated with it? 4-2 is off limits. How do I say that 4-2 is still my extrema? Like a union approaching it? Like, could I do something like, could I say something like relative minimum approximately on that interval? Like, do a union of 0 to 4 union 4 to infinity? Like, there's a relative minimum there-ish, kinda, I think. God, that looks weird. Like, I genuinely don't know, and this is okay. Because I've never seen an open circle at an extrema point before in PreCalc. In fact, I'm going to go talk to Mr. Spear about this and say, like, have you ever run across this in calc? Like, that's an alien concept to me, where normally we have continuous values. Could I say, like, relative minimum as x approaches 4? Like, which one kind of looks better? I'm asking you, which one seems more intuitive? Okay. Relative minimum as x approaches 4, because then we know we can get really close to it? All right. But that's a really good question, because honestly, I've never run across that before. Okay. So, no, it's okay to not know stuff and then to explore it. Sometimes you don't get a perfect answer. Like, I agree. I think that second one kind of looks, I mean, it's using the right kind of notation where most of us would probably know what that meant, but I don't know that that's official proven math notation. Okay, it could be someone just BSing, you know. You ever get someone just lay out the best story ever in the middle of a conversation? They're like, yeah, that never happened. They were just ad-libbing the whole time. Okay? It might be, but I thought that was a very, very interesting concept there. How'd we do with some of the other ones? Like, I think I did this one, right? Okay. No extrema to it at all because of the curvature to them. I know I actively didn't pick this one because of that straight line there. How do I say it's an extrema? It's an entire 6-unit range, right? But would you still be able to tell me increase, decrease, constant? Yeah. All right. So we left off with, it'd be funnier if there were peaches because then you could have the old 90s song. Moving to the country, gonna eat a lot of peaches. But I think we all found the maximum on that one eventually. Like, did you plug in your two binomials and then go find the maximum for it? Oh yeah, that's right, because we were arguing about how many trees we should plant, right? Because it was, the vertex was 0.5. So you could either get, what was it, 61 or 62? 62 or 63 trees, and I think we kind of settled on, well, if they're going to get the same result, do the one that costs less money and has less effort. Make 62 trees. Okay. Then, I know it's been a hot minute since y'all done geometry. A glass candle holder is in the shape of a right circular cylinder. Has a bottom and no top, indecent exposure, and a surface area of 10 pi square inches. Determine the radius and height of the candle holder that will maximize volume. This is very, very, like, in Algebra 2, Pre-Calc, Beyond, ACTE, they love this as an application problem, where you need to take the perimeter of a figure, rearrange it to put into the area formula. Or, in this case, take the surface area formula, rearrange it, and plug it into the volume formula. I know you've done this before, because I go on this rant in Algebra 2 as well. Do you know what these formulas are? The surface area of a cylinder and the volume of a cylinder. I ain't gonna tell you, figure it out. What are those formulas? What? Okay, a couple of you got the idea. Google that crap. It should be in the back of your textbook too. I think there's some formula pages there. Like, what are those formulas? If you don't know, look it up. That's what a functional adult does. Then we start debating the definition of functional. Yes, I get it. Okay. Anyone find it? Okay. The volume, pi r squared times the height. Because think about it, area of a circle, pi r squared, and you're stacking that circle h tall. That's volume, right? Area of the base times the height. Okay, what about surface area? You remember probably back in middle school doing a map of this, or maybe you even had a physical object that you manipulated, cut it open or something like that. If I cut this can open right here and lay it out, what shape does it make? Okay, so I'm going to have a circle on the top, I'm going to have a circle on the bottom, I'm going to have a rectangle in between them. Okay, then we go back and read it, and it says it has the bottom of the candle, but it doesn't have the top to the candle. So if this isn't here, how do I change my formula? 1 pi r squared, not 2, because I don't have 2 circles to worry about. They told you the surface area, and I'm telling you, you're going to have to monkey with that formula to plug it in here, because right now, I do not have volume equals something with 1 variable. I need volume equals something with 1 variable so I can dump it in my calculator and find the maximum. Y'all passed Algebra 2, y'all passed Geometry. Let's see what you can come up with. Problem solve. Like this could have been taken straight out of a geometry textbook. I know I did one an awful lot like that in Algebra 2. Listen to the Kate to the Y's. She's like, recognize.
First two.
You could, but notice that R has a regular R to the first and R to the second. Solving for R would involve completing the square. Yes-ish. That's one way to go about it. There's an easier way. Subtract one thing, divide by another. Hi.
No, I don't know how to lie.
What do all these have in common?
Pi.
Divide everything by pi.
Oh. What is this H doing down here? That's
We need to solve for H. Yeah.
You divide by pi.
Right? They all got that in common. Make your life easier. GCF stuff. Now, what would you do to get that H by itself?
Divide.
Okay. Y'all don't overcomplicate it. This is no different than that. It's just a bigger, uglier version of it. It's just a bigger, uglier version. See, because if you get H equals stuff, now you can go to that volume formula. And if H equals stuff,
This makes no sense. I just think it's stupid. Do you get H alone? Is that what we're doing?
and divide everything by 2R.
Did you just put it in a calculator? Yeah.
Yeah.
Because I don't know how to distribute that.
Yeah. Your calculator doesn't care how it graphs it.
It's just very right or
You get something like this, right?
Okay.
Because you
Yep.
subtracted this. And
What all three of those terms have in common?
pi
Dividing out.
h equals pi.
Oh yeah, I think I've said that before. Y'all, don't you dare use 3.14 or 22/7 as pi. Use pi button. Okay. And now, no, divide by it. Divide by pi, divide by pi, divide by pi. Bye-bye.
Just get that.
So if H is this junk, look at your volume formula.
That's that. Right there. So it's.
And now your volume will equal junk with only R. Yes. Divide everything by pi to simplify. And now if H equals junk, replace H with junk. Okay. We might be kind of dancing around it, but we're getting the idea anyway. First things first, I'm gonna make my life easier, divide everything by pi. I noticed that R would be kind of tough to get by itself because I'd have to complete the square. Y'all, you can complete the square right now. If I treat this as 2h times R, half of 2h is h. Square it and add it to both sides. Add h squared to both sides. Write that as the quantity R plus, what would that be? R plus h is this stuff solved by square roots. You could do it. It's just nasty. Instead, I'd rather get h by itself. We'd have 10 minus r squared is 2rh. Divide both sides by 2r. And if h equals stuff, now my volume formula, volume is pi r squared times h. Well, I just said h is stuff. So volume, in terms of just the radius, is pi r squared times 10 minus r squared over 2r. I could leave it like that, or I could distribute in. Because your r is going to cancel. So I just distribute a pi up top and leave it all over 2. Volume in terms of radius is 10 pi r minus, and pi r times this stuff is a pi r cubed over 2. Remember, because this is going to make r squared and this is going to make r to the 4th, but they're both over r. So they'll reduce. Okay. So you don't end up with a quadratic this time, you end up with a cubic. But regardless, could I type red or orange in my calculator and go find my maximum. This isn't very big. Like, it's a candle. You're talking about the radius of a candle. I want you to think about how big a candle do you really have? Like this? You know those little like Bed Bath and Beyond ones, or that whole stinky aisle in Walmart? Aren't they about that size? Like half of this? Okay, so your answer ain't going to be very big. Radius is going to be, I don't know, like somewhere between 2 and 5 inches or something. Like even 5 inches, that's a candle like that. It's like a flamethrower.
Why is it 10 R squared?
What? Right here?
Yeah.
Because I took this R and I canceled them. So I distribute a pi r to both. You would have a 10 pi r squared here and a minus pi r to the 4th here, but then it'd be over 2r. And you could reduce all of them. Okay? Yes, ma'am?
This right is not reduced.
Yeah.
Try this. That's the same thing as what you have? Or no? Because I didn't cancel
You
the
got a
I didn't cancel
extra.
the pi at the very first step.
You got one extra pi in there.
Because you canceled the pi on like the very first step. You went through and canceled all the pi, and I didn't do that.
But the most you should have then is pi times pi. I don't know where you got pi cubed from.
Because
H is, where'd that pi come from?
I don't know. I just isolated the
It should be 10 pi minus pi r squared.
10 pi.
I don't know where your extra pi there came from. Because you subtract this over to the other side. So you'd have 10 pi minus pi r squared divided all by 2 pi r.
Oh, so I just have an extra one.
Yeah. Okay. So change that to a squared and then you should be good to go. Okay. This is this is almost the textbook exemplar of geometry meets algebra, where I'm able to rearrange a perimeter, area, or volume formula to plug it into one of the other two. That's very, very common. Dump it in your calculator, go find a maximum. It's not going to be that big. If it was any... Yeah, X for R because I can't choose R. Yes, ma'am?
Do I put left bound in that line, right bound in that line?
That is... That graph looks like this. It's just super, super... because you didn't reduce this part, you're going to have it over R, meaning there's a hole right there. That's why it looks funky in the middle. So you're going to want a... Don't say between 0 and here. You got to move a little over because of that hole. So say between like 0.1 and whatever to find your maximum. It's going to be way up there. Whoa! Because you didn't reduce. This is going to have holes all over the place. Because now you have a cube down here.
But shouldn't it like? I feel like it should be the same graph if I don't reduce it, right?
The end graph should be the same. You should just have holes all over the place. I don't know why you're getting it. This is why we reduce. Okay, reduce. They all got r squared in common.
I thought you can't reduce if they're subtracting on the top.
What? No, this has an r squared, this has an r squared, this has an r squared. This has a pi squared, this has a pi squared, this has a pi squared. So call it a 10. Shoop, shoop. Okay.
No, No, just unless this equation is completely wrong.
Where did you get another? You got an extra pi down here too.
I don't know. I don't know.
You got an extra pi over here too. Reduce along the way, child. I swear you were taught by Gabriel. Oh God.
Yeah, I got 19 something something. What's the correct answer? Let's just look at the back of the book. It got divided by 5. I got like 100,000 something divided by 500,000.
What did you get? Nothing.
Yeah, no, that's if you keep it in fractions. It's just so that if you do it like that, it's gonna spit out a really nasty fraction.
I'm okay with that.
Well, you can't see the whole thing.
Yeah, I'm right. I got 1.8 for X. You got 1.8 for X?
Yeah.
And like 19.1 for Y.
Maybe someone said that X.
I got 5.
Y'all, it's a candle, not a bonfire. Okay. Window. You're talking about the radius of a candle. I'm betting it's from 0 to. If you got a radius of 10, your candle has a base that big. Okay? If you're talking about the volume of a candle, it's not a candle like this. Okay? I don't know. I think even if I went to like 100, that still might be overkill. So I said my window. I went up to 100, and I said that'd be overkill. Okay. I told you this isn't that big. Come on, Frank. Come on. Come on. You can do it. Calculate a maximum between 1 and 3. I said between 1 and 3.
No, it's not the same thing.
Maximum.
Yes, yes. We can do math from our back.
It does look like that chair.
Yes.
You got it, Frank.
Yes.
Frank.
What?
Yeah, let's
You were
go.
right.
What
Okay,
in
I
the
complete the square and I got something totally different.
I didn't complete the square either.
Oh, what hey, sorry. I did too, and I did not get it. Hey, well, all I did is I just
All right.
I just want to point out that I did it.
Okay.
I'm like,
Do you understand I plug in 10 pi for my surface area?
yes, but there's no square.
No. It's in the original problem. It says surface area is 10 pi. Now, it is surface area, so it's 10 pi units squared,
Oh, that's why I did it wrong.
or whatever it said in here, inches maybe. Okay. So it'd be 10 pi square inches, yeah, but I don't square the pi, I'm squaring the units.
That's why somebody working on the same.
Okay. Yeah.
How do I like see the Y thing? Like,
What would be your Y
Because mine's
maximum?
not in.
Whatever.
I don't think. I have the same equation.
Okay. So if it's going to spit out nasty fraction because we typed it as fraction, you can go to mode and you can switch your answers over to decimal so that it will automatically spit that out for you.
Calculate the
Settle down there, Tiny. Jesus. Okay. Now that I'm over in decimal town, If I calculate a maximum, it should give you the
Why
same
can't I see
thing.
my little pointer? It's like I'm trying to calculate the max.
Look at where it is.
11. I don't even know where I'm at here.
Well, if your window goes
Okay, I
out to
got the same
30,
thing. Okay.
then 11 is like way over here. So you're like down in the floor.
Oh, so I need to go up. Oh, got you.
That's why I always just, there you go. Then, okay. Okay. Well, it looks like we found about half of our problems was we were squaring something that wasn't supposed to be squared. Okay. So, over here, purple. Do you see that pi is complicating this? So reduce it. Okay. Now, there's a lot of kids who will take PreCalc with me. They'll take calc with Mr. Spear, Algebra 2. And we try to really harp on accuracy. I'll just let y'all know, if you're going to go take physics, I have been told, I'm not in anyone else's classroom. I don't know how they do things, just like other teachers aren't in my classroom. I'm not going to speak to that. But I've been told by kids that Mr. Gabriel likes to round at each step of his work. In physics.
He always told us to store the decimal in one of the
Okay. Okay, good, good. Like, I've heard that, and that terrifies me because of things like this. Like, Holly had like a quartic with pi cubed in it because we weren't reducing along the way. Always reduce and simplify as you can along the way so it's less complicated. Okay? So, do you see that this rearrange gets this little dude? I should just be able to type pi r squared times that. If you do this, notice that there's an r here that can cancel. You will get the same graph. There's just going to be a hole at 0 in the middle because r's cancel, so there's a 0 hole. You could just type this and you'd be good. We're over here getting like candles the size of shark pits, and yeah, the answer was the radius is 1.8 something with a maximum volume of 19 something cubic inches. Okay. Oh boy. I gotta find. All right. I'll just tell you right now, I'm going to find an old problem like that out of an Algebra 2 book, and I'm going to put that on tonight's homework. Okay. Okay. Bring it back. Next up, rate of change. What's another word for rate of change that you've been dealing with since middle school? Slope. Okay. Rate of change is slope. So like when I tell you my wife's vehicle has an average gas mileage of 28 miles per gallon. Okay. Miles per gallon is a rate. It tells me I will go up this many miles for this many gallons used. Okay. Now, how do I do that when it's not a line? How do I say, what's the slope of that? And it's a curve. You go take calculus. Okay, because that's actually what it is. Okay, it's a derivative. A derivative is an entire function because that might be the slope here, but the slope over here at that point of tangency is here, at that point of tangency is here, at that point of tangency is here. That line is going to keep moving as I go along the curve. The slope of the line is an equation by itself. And it's actually super simple. If I have something like y is negative 2x squared, y'all know that that's a downward parabola, right? The slope of this line is negative 4x. Any point along that parabola, plug in x, take negative 4 times that, that's the slope at that point. Okay? That's calc, or the beginning of calc, as you start to do function analysis and then get into derivatives. After that, you'll do area under the curve, where you want to find the area under this space, which normally we can't do because it's curvy, right? Like you would make, you ever remember doing something like this? Like you'd find the area of all these separate rectangles and add them up? Okay, it's usually like a high-end application in geometry. So, that's where all of this is headed. Right now, we can't find the slope of a curve. So we're going to BS it with what's called a secant line. Y'all remember hearing tangent lines and secant lines with circles in geometry? I hope. If I have a circle, this is a line of tangency because it just bullet grazes it at one point. This is a secant line because it doesn't bullet graze it, it just goes through it. Do you remember doing something like, if this is x and 5 and this is 6, I would take 6 squared equals, what is it, 5 times x plus 5? Remember doing those? Okay, it's been a long time since I've done it. I'd have to look at the formula again, but you should have done something with tangent and secant lines in geometry. So that's where this terminology comes from. A secant line is a line that goes through a curved space. And I said we're going to BS it. So if I don't know what the exact slope is from here to here, or the exact rate of change, because it keeps changing, I'm just going to average it. I'm going to average it by literally finding the slope between those 2 points. The way that I write it, though, notice that the function of this value is to give me the y. So they're going to write, instead of this guy, remember that? And you're like, oh God, I remember the good old days. Bring it back. We're going to change that, and now we're going to write it as, nope, because it's change, I say delta x. Change. Delta is change. And I'm going to write it as the function of x sub 2 minus the function of x sub 1. Do you see that that is a more complicated version of this? Okay? It's still just find the slope. So since I don't have the skills yet, or I don't have the content knowledge to find the rate of change on a curve, I'm just going to ballpark it with a slope by putting a line between them. Right, talk about gas mileage, that's kind of what your vehicle does if it calculates gas mileage. You know, you get to the end, does anyone ever look at, like have a display in there that shows you your mileage? Okay, most vehicles in the last 20 years have that. Your gas mileage is different between I'm traveling 60 miles an hour on this highway, back and forth all the time, versus I'm stomping it to get around grandma in town. Your gas mileage changed, and it averages them together. It gets a ballpark, okay? Like, I'm moving snow, my truck is down at like 8, 9, miles per gallon. Regular commuting, it's more like 18, 19, okay? Silverado. 16 or 17.
What's your license plate? Why are you avoiding the question?
You want to know my blood type, my social security number, and my underwear size?
That would be good too, yeah.
Dude. Okay. So, they're going to say find the average rate of change along an interval. Y'all, when they give you an interval, isn't this an X and another X? An interval, like when we do domain? So that's my first X and my second X. If I want to find my rate of change along that interval, what else do I need with them? Right? Y'all in high school, if you got an X, you better find out Y. So I'm going to plug in the function of -2 and get -2 cubed plus 3 by -2. Getting -8 times the negative is +8 minus 6 is 2. I'm going to plug in -1. Maybe it shouldn't. I'm plugging -1. -1 cubed is -1 by negative is just 1. Minus 3 is -2. So I have to take that coordinate and plug it in order to find out effectively, or not coordinate, that X value, and plug them in to effectively get, I'm going from the point -2, 2 to the point -1, -2. So on my graph, this cubic goes from -2, 2 to -1, -2. So it's curving down like this. Okay? They're asking you to find the average rate of change along that interval. So you go find the slope with those 2 points. Hopefully you all remember basic slope. We also just wrote the formula for it. This is x sub 1, function of x sub 1. X sub 2, function of x sub 2. So I'm going to have a -2 minus a 2 over a -1 minus a -2. And if you remember from the ancient times, remember the ancient magic, which was, please use parentheses. How many times did you screw up basic slope just because you missed the negative? Okay. Please use parentheses when you're plugging those in. And so at the end of it, we're going to say that my delta, my change, is -4 over 1 is -4. And if I asked you, along this interval, is this function increasing, decreasing, or constant? It's decreasing because the average rate of change is negative. Which, quick sketch of graph, wasn't it going down left to right? Okay? So what we're doing is taking basic concepts that you know from throughout your academic history, and we're starting to formalize them. We're formalizing the notation so that they work with everything, with all of math, not just lines. Okay? Now I wrote all over this space, so I'm not going to worry about B here. Instead, I'm going to say, you go do them. Those two. Find the average rate of change on those two intervals. A and B. I skipped B up there. You would have heard me if you weren't busy blabbing at Sammy. 5A, 5B. Cross out little b. Okay, what we should be seeing here is there's a lot of familiar concepts. It's just we're cranking it up to 11 because now we are using formal definitions. It's kind of like in elementary school, you know, basic rules like don't bite people and don't take people's snacks. Well, you get older, it's the same rules, they just get more formal. Don't infringe upon another person's rights. Don't take their property, which may include intellectual property. Like, don't take someone else's good idea at work and claim it's your own.
Or do you want me to?
Yeah. Well, yeah. If you want to type it out manually like that, if you want to put it in Y1, Y2, whatever your jam is, you just have to find the Y value that goes with them. So what's that? 2880875 -6 75 -4. That's why I crossed out little b and said do these ones. 753 27 92 18 9 9 minus 9 0 2. Minus -1. 5 -5 5 625 675 25 6 150 625 4 75 3 75 5 -3 81 81 9 9 54 54 81 27 27 minus 12 is 15. Oh.
You can use it, but I thought I like
6. X -360 over 2 -1. I did mental math before lunch. Check me before you wreck me. Well, I might be wrong.
2 minus the -4 is 2, right?
No, minus a negative.
Oh, okay. Yeah.
Mental math before lunch is dangerous. Check me.
The first one is dumb that you can say.
Okay.
You have it right. I just checked it. Okay. No, for the value. I like my what else would I be talking about, Lord?
I mean, at least we're not creepy quiet. So 625 minus 150. -5 squared is 25. 25 by -6 is -150. So then 625 minus 150 is 475. 475 minus 100 is 375. Right? Oh! I did times 25 here. Oops. That's why I have a question mark on there. That's my insurance policy. So 625, 475 minus 455. There we go. 75, 75, 8, 81, 75, 9, 54, 27, 27 minus 12, 15. 75, negative 440, 75, 2, negative 220. So negative 220 this time?
Yes, that is correct.
Okay. Yeah, first time I did 4 times a negative 25 instead of 4 times 25, or 5. So. Okay, so I at least got the y values on there so we know we're getting it right in stages.
So on this one,
Mhm.
it was negative 4 over 1, but why isn't that negative 4?
It was.
Yeah. Oh, I just didn't write it.
No, those are, y'all, questions of clarification are good. I want you to ask and clarify. I want you to stop me. I want you to say, no, no, no. Writing 2 numbers up there isn't enough. Go through it. If you need me to go through something, if you need to stop me and double check something, if you're in pre-calc, odds are you're used to math going well for you. You might have to try now. And that might mean little things like, wait, wasn't that supposed to be negative? And then we go through it. Okay?
I got, that's not what I got.
Yeah.
I got something totally different.
Uh-oh.
I got negative 460 over negative 18.
Well, we got 455 and 15. Oh, you have a 5 here instead of 15. Remember, this is the y value. Y minus y. We just swapped x and y on one of them. I did that the first time with 5a. That's why I had 1/6 instead. Yes, ma'am.
So when I put
Your
it
handwriting is so neat.
Thank you.
Like it's like typeface. Okay.
So when I put it into these, would it go that way, or would the negative 4 be up front? Like,
That's why I would label them. x1, f of x1.
okay.
x2,
But
f
that
of
would be the
x2.
right order because I had negative 4.
We always go 2 minus 1. Second one minus first one.
Okay.
So second one minus first one. 2 minus negative 4.
Okay. Thank you.
Yep. Ruh-roh.
No, my graph.
Talking
I
about
can't. I don't know what I did wrong, unless I just typed it in wrong, or. Okay, that's what I put in my calculator.
I think you still have an extra pi over here, don't you?
Well, that was just old work. So
Oh.
then I redid it. So then now I'm here.
Well, now you're missing a pi.
Well,
Okay, so pi r squared times this. Yes.
that's what. Yeah, that's what
Okay,
I put
so
in my
pi.
calculator.
You got an extra pi down here.
How
When
am I
you
getting
no,
extra
no.
pies?
When you distribute this, put that over 1. The pi goes to the numerators. The r squared goes to the numerators. You
Does
do
it
not go to the
denominator?
Because then you'd have pi r squared over pi r squared, so you're not multiplying by pi r squared, you're multiplying by 1.
So then I put this. There's no pi on bottom.
No pi on bottom.
That's what I did wrong. Okay, so then just 2r? Yeah.
I think so.
Okay, now if I.
That looks like about 1.8 something. I think we're there. I think we're there. I think we're there.
I don't know why it starts off so low.
Give her hope.
Did you say it's still gonna be wrong?
Just type like 0.1. You don't have to move
I have
blanky.
to move the whole thing.
Okay.
'Cause it makes sense to me that way.
All right. No, that's good. Like if you know that's the thing that makes sense for you, there it is.
There's no pi on the bottom.
You swapped your 5 and 15.
Oh, I did. Yep, you're right.
All right. So it sounds like as long as we're careful, and y'all remember back to Algebra 1 when maybe some of your peers had to keep writing x sub 1, y sub 1, x sub 2, y sub 2, but you never did that because you're like, this is easy, I get it, I can just put it there. Now you might want to do that. Little things like that, these little steps that help us to be more accurate might be the difference between the kid who has the A and the kid who has their first B or C and freaks out. Little things like this. Okay? Just walking around the room. Like walking around the room, the stuff that I'm seeing, the errors that I'm seeing, this isn't big King Kong holy crap things that I don't understand math. This is, I missed a negative. I swapped my 5 and 15. I put 2 before 3 on here, but then I put this 2 before the -4 down there. It's little stuff that affects our accuracy. Okay? You got it. You just need to slow down, attention to detail, write more things. Y'all, the very first time that I taught PreCalc, back up like 15 years, I sucked. Because it had been a long time since I'd done it, it took years of writing it out and explaining it to kids to know that I have to write every single stage before I started being more accurate. Everyone runs into the wall at some point. Everyone will hit the point where now you have to try. Everyone's going to hit the point where you're going to have to study or it's going to be difficult. Slow down and write things. Take your time. You don't want to be 21 years old in abstract algebra and ring theory before you have to figure out how to study. Okay? It sucks. That was a very specific example. Yeah. My capstone course for both of my majors, they just handed me the book and said, tell us when you're ready for the final. Like there was no instruction. It was just read this textbook. Tell us when you're ready, because I did an independent study. Abstract algebra and ring theory, when you prove why math works. It was the first time I hated math. And then it clicked, and you go back and look at an elementary textbook where it says 2 + 3 = 5, and you go, oh, dude, because you can see the matrix behind it. It's awesome. Anyway, again, but now there's words. Y'all, bring it back in. Find the average speed. And it says the height of an object thrown straight up from a height of 4 feet is given by this equation. You may not remember it precisely, but does this look familiar? The vertical motion model is -16t² plus v sub 0 t plus h sub 0, where this is my initial velocity. This is my initial height. And gravity is constant. This model goes all the way back into Algebra 1 when you first learned parabolas. So do you see now where that equation came from? I threw it upward from a height of 4 feet. You see why it says +4 at the end. Why is that a 30 t? Initial velocity. That means they took this thing and chucked it up in the air at a speed of 30 feet per second. Okay? So you're going to have a graph that has time and height. Okay, this isn't horizontal distance and height. It's as time goes along, how high up is it? And it hits a maximum and then comes back down, right? Doesn't it get slower the higher it goes till it hits that peak? And then as it comes back down, it accelerates. That's why it's going to create a parabola like this, starting at 4. Okay, so this vertical motion model should be old news to us. Maybe we didn't formalize it by writing it like this, where those two numbers are input by us. So, find and interpret the average speed of the object from 1.25 to 1.75 seconds. So they're saying from, and I'm just guesstimating, I don't know where these actually land, like from here to here, what is the average speed? Isn't that what we just finished doing? Okay, plug it in, find out. Function around and find out. What did I just hear? I'll break out that dinosaur if I have to.
There's a dinosaur. Sorry, look in front of your face. I just saw that all my friends are graduating this year.
Child, if I have to
I'm sorry.
If I have to censor myself in this building, then you sure do.
Oh my God. That's okay.
We're aware. We did know that.
It's okay.
You sound a little too proud of that, Ava.
The day that you find me censoring myself, the day that I die.
That dude.
Hey, yo.
I found the things.
Okay, now you have a coordinate.
Yes.
You have 1.25 this, 1.75 this. Find the slope between them.
Okay.
That seemed right.
That's what she got.
It was the adding that I kept putting into my calculator wrong. And that was my problem.
This.
Y'all, work smarter, not harder. Dump that in your calculator. Come over here and say at 1.25 and at 1.75. Okay? And now, those are literally the coordinates. Okay? So now, my delta is 7.5 minus 16.5 over 1.75 minus 1.25.
That's what I got, but I didn't do it.
Okay? Now, maybe it was because you saw quadratic and you're like, okay, familiar territory, and you just started writing stuff with parentheses. Okay, it'll work, but work smarter, not harder. Okay? Let the calculator do the heavy lifting for you. All right? Now, interpret this. I got my average rate of change was negative 18. What does that mean? So the slope at that point on the parabola, or between these 2 points, is negative 18. What? Look back at the context of the problem. So it is going downward at a rate of 18 feet per second in this time interval. Okay? I mean, you think about what are these speeds? Like 30 feet per second. Each one of these tiles is 12 inches.
You should have said that, Jacob.
Okay? 30 feet in 1 second. Okay? I had to be careful how I did that. I am not joking. My very first week in this school district, I tried that example in an Algebra 1 class, and I kind of beamed a girl in the face with a marker. Was Cor-
Did she deserve it?
No, she was a sweet kid.
Okay.
Cora Tobin, years and years ago. Like she's like out of college by now, right? Yeah. Very first day of like freshman Algebra 1, teacher beans her in the face with a marker. I felt terrible, but at the same time, it was also kind of funny. So.
Did you laugh? Comfort her first.
It was just shock. Like. Okay. All right. Y'all cool. Dump stuff in, get points, plug in slope. Okay. Just cross this out. We good. All right. I want y'all to stare at this page and say, like, look at all of them. It's like a lineup. Okay? Like you're flipping through mug shots. I want you to look at each of these and say, I know that guy. Like, are you familiar with each of these types of functions? Like a constant slope is called the constant function. Okay. A regular line technically is the identity function because y equals x. Input is output. Are you okay with a square root? You know where to start and do your perfect squares on their side to make a square root function? Parabolas, we've covered in detail. Cubes. You all know that they're going to still run with cube steps, right? Over 1 up, 1 cubed is 1. Over 2 up, what? 8. Over 3 up, 27. Okay, so it still follows the same patterns, it's just now they're cubes. Same thing goes for fourths and so on. It sounds like we're a little bit rocky on the reciprocal functions. Remember that they're going to have asymptotes, both vertical and horizontal. And when I translate this thing left and right and up and down, what I'm doing is moving the crosshairs. And then it still makes those same little swooshes on either side of the crosshairs. Okay. Y'all remember absolute value? The slope on the right-hand side will be the combination of your vertical and horizontal dilations. Take A times B, and that makes your slope on the right side. When I think I made a quick graph of this last week, and everyone kind of panicked. Greatest integer function, also called step function. I think I mentioned it once in my Algebra 2 and probably got the exact same expression that's on your face right now. The last time you would have saw it would probably be all the way back in Algebra half. So this is when I'm not allowed to have non-integer values. Think about it like how many of a thing you're allowed to buy. Okay, you got a bunch of money, you're gonna have a bunch of your friends over, and how many pizzas can I buy? Well, you get money, you can buy a pizza. What happens when the pizzas are like $7 a piece? You have $8.95. You can still only buy one pizza. You have $13.95. You can still only buy one pizza. And then the second you hit 14, now you can have two pizzas. Okay? We're going to assume that it's rolled in as a part of the promotion. Okay? Like another example, okay. My oldest is about 5.5. When he was in preschool last year, you could always tell when he learned a new number because that was the biggest number he had ever heard. He'd say, "There's 15 houses over there." Like there's like 5. He was like, "There's 15 houses over there." "Really, bud? Cool." And then the next week it was like, "There's 100 houses over there." Because that's the biggest number he's ever heard of. Think about it that way. If I'm at 0, what's the biggest integer I've ever heard of? If I'm at 0.83, what's the biggest integer I've ever heard of? Integer. 0. That's the biggest whole number I've ever heard of. Until someone says, "Hey, there's this number called 1. Dude! And then when you get to 1.7, what's the biggest integer you've ever heard of? 1. Until someone says, "All right, now hold up another finger." Dude! 2. So that's why you keep getting these closed to open circles, closed to open circles, closed to open circles. And that's also why we call them step functions, because it looks like steps. Okay? They're really easy to work with. They're annoying as all get out to graph. Okay? So, you look at that page and you tell me that you are familiar with these, or, yeah, I can do it. I don't like it, but I can do it. Okay, then tomorrow, y'all remember transformations that we beat to death in Algebra 2. Tomorrow we will do transformations. Next quiz will be Friday. Like at the end, almost the end of every chapter, you went through the transformations of that type of function. So tomorrow should be easy, but it is expecting that you know how to graph every one of these types of functions. Well, you at least got a C in Algebra 2 or you wouldn't be in the room.